Timeless concepts from Physics Helpline. In this video tutorial, we will discuss a multiple choice question taken from JEE Main Physics question paper of 2023. The question is based on laws of motion, in which we will discuss about a system in equilibrium, and we will determine the tension in the string. Read the question carefully. An object of mass 8 kg hanging from one end of a uniform rod CD of mass 2 kg and length 1 meter pivoted at its end C on a vertical wall as shown in the figure. It is supported by a cable AB such that the system is in equilibrium. The tension in the cable is, take G is equal to 10 meters per second square. The options are given in the question. We are required to find the correct option. Now for the solution. It is given that the system is in equilibrium. Therefore, for translational equilibrium, we have sigma F is equal to 0. That means the sum of the total forces, vector sum of the total forces is equal to 0. And for rotational equilibrium, sigma tau is equal to 0 about any point. We will use the condition for rotational equilibrium, that is sigma tau is equal to 0 about point C. Let the tension in the cable is T. Let us draw the components of tension here. Let us mark this point also as D. Now we want the torque to be 0, the total torque to be 0 about the point C, this one. Therefore, the components of tension T along the horizontal component is T cos 30 degrees along BC and T sin 30 along the vertical direction. Now T cos 30, the horizontal component, passes through the point C. Therefore, the torque about C will be 0. So we can forget this component. We'll consider only this component. Now since sin 30 is equal to 1 by 2, therefore we have T sin 30 is equal to T by 2. Let us replace it here. When the system is in equilibrium, the total torque about C is equal to 0. Therefore, the clockwise torque should be equal to the anti-clockwise torque. Let us first calculate the total clockwise torque. At D, we have a body of mass 8 kg hanging at T. Now, the torque produced by the 8 kg body is clockwise about C, clockwise about C. Therefore, tau 1 is equal to, let's designate it by tau 1. Tau 1 is equal to weight of body into CD, the length. So the mass of the body is 8 kg and G is equal to 10 meters per second square. Therefore, the weight of the body is equal to 80 newtons into CD. CD is given in the question as 1 meter. So this is equal to 80 Newton meter. This torque. Let us remove everything and put it there. Now the second clockwise torque is due to the weight of the rod, which is acting at the midpoint. Let us designate it as E. Therefore, vertically downward from E, therefore it is equal to tau 2. Let's designate the torque as tau 2, which is equal to weight of the rod into the distance CE. E is the midpoint of CD. Now it is given in the question that mass of the rod is equal to 2 kg and its length is equal to 1 meter. Therefore, from one end C to the midpoint E should be equal to 0.5 meters and mass of the rod is equal to 2 kg. So it's given that mass of the rod is equal to 2 kg, therefore its weight is equal to 20 newtons because G is equal to 10. And its length is 1 meter, therefore up to midpoint it will be equal to 0.5 meters. So 20 newtons into 0.5 meters, which is equal to 10 Newton meters. Let us remove everything and put it there. Therefore, adding these two, we get the total clockwise torque is equal to 80 plus 10 is equal to 90 Newton meter. So this is the tau. Tau is equal to means clockwise torque. Total clockwise torque is equal to this. Now let us remove everything and put it there. Now for anti-clockwise torque, which can be produced by the only force available, this vertical force acting at point B, which is equal to T by 2. Because we have already calculated, it will be, if tension is around in the cable is T, then this will be equal to T sin 30, which is equal to T by 2. Now it is given in the question that C to B is equal to 60 centimeters, that is 0.6 meters from C to B. Therefore, the total anti-clockwise torque is equal to T by 2 newtons into 0.6 meters, which is equal to T into 0.3 Newton meter. Let us remove this and put it there. Therefore, for equilibrium, the total clockwise torque should be equal to total anti-clockwise torque. That is, 90 should be equal to T into 0.3, which gives T is equal to 90 divided by 0.3 is equal to 900 divided by 3, which is equal to 300 newtons, which is the answer to the question. Therefore, the correct option is 3. 3 is the correct option. This completes the answer to the question. Thanks for watching.